Subscribe to Emmanuel tutorials and press the bell icon for notifications.
Now we'll see the next example. Here we have considered the operation as x of minus 1 by 3 n minus 1. So first we'll draw x of n. This is x of n. And if we follow the same like the previous ones, it will be x of minus 1 by 3 and n plus 1 inside the brackets. So it will be n plus 1 into 3, which is inside the bracket. Now first we will scale the signal by minus 1 by 3. First we'll perform time reversal, so it will be x of minus n. So at minus 1 we have the amplitude as 1. So at 1 the amplitude will be 1. At 0 the amplitude will be 1. At 1 the amplitude is 2. So at minus 1 the amplitude will be 2. And at minus 2 the amplitude will be 1. Now we have to multiply this by 1 by 3. So this is, the number will be lesser than 1. So this is expansion by 3. X of minus 1 by 3n. So the signals will be like at 1 the amplitude is 1. So at 1 into 3 the amplitude will be 1. So at 1 into 3, that is at 3 the amplitude will be 1. At 0 into 3, that is 0, the amplitude will be 1. At minus 1 into 3, that is minus 3, the amplitude will be 2. And at minus 2 into 3, which is minus 6, the amplitude will be 1. So here it will be 1 here. So this will be the resultant signal. Now we have to shift it by 3 and the sign is plus, so it suggests advance. So we'll have to shift the signal to the left by 3. So the signal at plus 3 is of amplitude 1. This will be shifted by 3. So 3 minus 3 to the left. So it will be at 0. So at 0 the amplitude will be plus 1. At 0 minus 3, that is at minus 3 the amplitude will be plus 1. At minus 3 minus 3, which is minus 6, the amplitude would be plus 2. And at minus 6 minus 3, which is minus 9, the amplitude will be plus 1. So this will be the resultant signal, which is x of minus 1 by 3 n plus 3, which is x of minus 1 by 3 n minus 1. Now we'll see a continuous time example. X of minus t minus 5 by 2. So here the fractional part is at 5 by 2. Now let's draw x of t for this. So the axis is t, 0. Now similar to the previous examples, it will be minus 1 outside and t plus 5 by 2 inside. So first we'll perform time reversal. So here at minus 1 the amplitude is 0. So here at plus 1 the amplitude would be 0. At 0 the amplitude is 2. So here again at 0 the amplitude will be 2. At 1 the amplitude is 2. So at minus 1 the amplitude will be 2, which drops to 1 and then to 0. Now we have to shift the signal by 5 by 2, which is 2.5. In continuous time signals there will be decimal point numbers also on the axis, time axis. So this will be x of minus 1 t plus 5 by 2. Now this is again an advance. So we'll be shifting this signal by 2.5 to the left. So the signal at 1 will appear at 1 minus 2.5, which is minus 1.5. So it will be here. And the signal at 0 will be at 0 minus 2.5, that is minus 2.5, which will be here. So it will be like this. And the signal at minus 1 will appear at minus 1 minus 2.5, which is minus 3.5. So which is here. And then the signal at minus 2 will appear at minus 2 minus 2.5, which is minus 4.5. So this will be the resultant signal. X of minus t minus 5 by 2.
Subscribe to Emmanuel Tutorials and press the bell icon for notifications.